Hello, Algebra 2, and we're going to be solving in this first problem. Remember, we're going to be looking for P's over Q's. So as we discussed in class, there's two different questions here. So if we just want to list the P's and the Q's, remember this guy down here is P and this coefficient up here is Q. So when Q is 1, that's beautiful, because if we were actually going to list the P's over the Q's, it would just be plus or minus 1. I'm doing factors of 27. Plus or minus 3, plus or minus 9, and plus or minus 27, all over the factors of Q. And when Q is 1, it's just over 1, over 1, over 1, over 1. So, like we discussed in class, always start with positive or negative 1. That's always the easiest thing. So let's start with positive 1. And remember, we're doing synthetic division, what we like to call yo mama's division. So 4, 3, 2, 1, none. We're ready to go. 1x to the 4th, negative 2x to the 3rd, 6x squared, negative 18, negative 27. That last column is our remainder, and our goal is to get a 0 there. So let's bring down the 1 and then multiply, add, multiply, add, multiply, add, multiply, and add. And we get negative 13. 1 times negative 13 is negative 13. This does not give us 0. So just put x through it and let's go to negative 1. So same numbers again, because we're just doing synthetic division again. Here we go. Bring down the 1, negative 3, 3, 9, negative 9. And here's our winner right here. There you go. Remember, we want a remainder of 0. If we get a remainder of 0, we know we indeed have a factor. Therefore, our first 0 is this guy right here. He's a winner. So negative 1 going right up there. What do we have left? This is our quotient. What did we just do? We just depressed this polynomial. So we just went from a 4th degree down to a 3rd degree. X cubed minus 3x squared plus 9x minus 27 equals 0. Now you can use another one of your P over Q's up here, or what I just happened to see right here is I think this guy's factorable. Let's give it a shot. Let's factor it by grouping. So here we go. X squared is coming out because they have an x squared to give up front, which leaves us with x minus 3. And then that sign needs to go right there. I should have put it on the other side of the line. Take out a 9, and we have x minus 3. So this guy is factorable. Look for options to factor on our test. That's why we practiced it. So what do we have? We have x minus 3 times x squared plus 9. So these are factors. X minus 3 equals 0. Set each factor equal to 0. So x equals 3. There's our next answer. And then here, x squared equals negative 9. Negative 9. Emphasizing that we're about to take the square root of a negative. That is plus or minus 3i. So we have two real roots, which we can see in our P's and Q's. There's negative 1, there's positive 3, and we also have these two imaginary roots, plus or minus 3i, giving us our grand total of, since it's degree 4, 1, 2, 3, 4, 4 answers. Look for a problem very similar to that on our test this week. Now we're going to go in the exact opposite direction. We're given the zeros and we want to write the polynomial. So first thing we got to do is we got to find all the factors here. So let's do it. Remember, each one of these zeros represents a factor. So x equals 0. There's the first factor. Next, x equals -3. To get the factor, we need to add 3 back to both sides to get it set equal to 0. There's the second factor. Next, x equals 3 plus 2i. Remind yourself that we want to isolate that I term. It's just like isolating the radical because I is by definition a radical. So we're going to start by subtracting 3. We get x minus 3 equals 2i. And then in order to get rid of that I, we need to square both sides. Square, square. And don't be lazy. Write it out. Think about it. Use the distributive property. 2 squared is 4. I squared is I squared. X minus 3 times x minus 3 is x squared minus 3x minus 3x plus 9. And of course, 4i squared is -4. Why? Because I squared is equal to -1. That's why. So next, let's add the 4 and set equal to 0. So x squared minus 6x, because these are like terms, plus 13 equals 0. There is our third factor. Our first factor is x. Our second factor is x plus 3. Our third factor is x squared minus 6x. So shifting it up a little bit, I think I've got just enough room here. So x times x plus 3 times x squared minus 6x plus 13, just like we've done in class. This is what our polynomial is going to be equal to. So this is in factored form. Let's go all the way here. So we're going to start by distributing the x, which gives us x squared plus 3x, and then we're going to multiply it by this trinomial using the distributive property. So here's what we're distributing first. First, the x squared goes all the way through. X squared times x squared is x to the 4th. X squared times -6x is -6x cubed. X squared times 13 plus 13x squared. Next, we're going to come back and we're going to take the 3x all the way through. So that is going to be plus 3x cubed. I'm lining up my like terms. 3x times -6x is -18x squared. 3x times 13 plus 39x. And now add down those columns for your final answer. X to the 4th minus 3x cubed minus 5x squared plus 39x is what your polynomial is equal to. Remember, the directions ask to write the polynomial. We found the factors, we multiplied them together to get the polynomial that has these particular zeros when we graph it. Next, let's look at some graphing problems which are on your review sheet that you received yesterday in class. So if f of x equals x to the 4th minus 9x squared plus 4x plus 12, we need to know what the zeros are. How do we find the zeros? We look at the p's and q's. So p over q, remember this is p, this is q. Once again, q is equal to 1. That makes our lives nice and easy. So what do we need? We need the factors of 12. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And remember, since q is 1 over 1 over 1 over 1 over 1 over 1 over 1. Yay! Now, always start with plus or minus 1. Those are the easiest ones. Let's go with 1. 4, 2, 1 and none. We are missing a power of x up here. So what do you need to do? You need to plug it in with a ghost term. So we're missing an x cubed. So put a plus 0x cubed up there. So that's going to be 1x to the 4th, 0x cubed, negative 9x squared, positive 4, and a positive 12. we're looking for a 0 here. Let's see if we get one. So this is going to be 1. When we bring down, remember to bring down, 1 times 1 is 1. That's 1. And 1 times 1 is 1 again. Add, remember this is yo mama's division. So 1 times -8 is -8. 4 and a -8 is a -4, and that does not give us a 0. Let's try -1. It looks promising. Same numbers again, 1, 0, -9, 4, 12. So bring down and multiply and add. Guess what? I think we got a winner here, and we do, because that's a 0. So therefore we know that x has to equal -1. That is one of our zeros for this particular function. So what remains down here? We've got 1, -1, -8, and 12. Nothing's going to factor here. So maybe we better go back and we better look for another 0. Let's try 2. And we're not going to use this number again, or this polynomial again. We're going to use remember, this is the depressed polynomial right here, all right? So we're going to use the depressed polynomial right here. All you got to do is bring those numbers down. I really didn't even need to rewrite them. That's okay, though. So, and let's go by 2 this time. So 2 times 1 is 2. That is 1. 2 times 1 is 2. And -8 plus 2 is -6. And thankfully, we get our other winner here, because 2 times -6 is 12. That is 0. So we have what remains right here. So we've got another 0. It is 2. And remember, if x equals -1, the graph is going to cross the x-axis at -1. If x equals 2, the graph is going to cross the x-axis at x equals 2. Well, what do we have left? We depressed it from first a fourth to a cubic. And now we have a quadratic, which of course is to the second power. So that is 1x squared plus 1x minus the 6, which hopefully everybody looks at that and goes, wow, factors of -6 that add up to 1 are going to be x plus 3 and x minus 2. So that factors very easily, and now we can see our other 2 zeros, because how many are we after? Woo! We're after 4, because this is a degree 4 polynomial. So we've got x equals +2 again, so that makes this a double root. So we already got it once. We get it again here. That means 2 has a multiplicity of 2. And we also have a root at -3. So 1, 2, 3, 4. So let's put our other 0 right there. Now, let's think about end behavior for just a moment. End behavior has to do with what is the degree? The degree is 4, so we have a degree 4 polynomial, and our leading coefficient, our LC, is +1. So if the degree is even and the leading coefficient is positive, this graph is going to be like a touchdown. It is going up and up. As x gets smaller, y gets bigger. And as x gets bigger, y still gets bigger. It's a touchdown, up and up, both sides. But something fantastic is going to happen at +2. Because it has a multiplicity of 2, we know that it is going to bounce. But at -1 and -3, it is going to pass because its multiplicity is odd. So passing, passing, bouncing. Here we go. Now, before I go any further, we also could find the y-intercept if we find f of 0, which is very easy here because that goes to 0, that goes to 0, that goes to 0. Boom, all we have is 12. So we can sort of fit this. If this is 10, 11, 12, we'll put our y-intercept about right there. and it goes through it and it comes back down. But now remember it too. What's it going to do? It's going to bounce, boom, right back up. That is pretty good view of what the graph of this function looks like. And this problem, wow, this problem has everything going on. So if you understand this problem, you should be in really great shape. All right, we got just a couple more. Number 13, same type problem, doing the same thing again. We're looking for the zeros. We got Q is equal to 1 and P is equal to 9. Our P's over our Q's, plus minus 1, plus minus 3, plus minus 9. Start the process over again. What do we start with? Positive or negative 1. Always the easiest thing. 3, 2, 1, none. Line them up. 1, 5, 3, and negative 9. Bring down the 1 and then multiply, add. And we got a winner right away. So x is equal to 1. Remember, whatever we're dividing by out here, if we get a 0, we have a true factor. So that is our first 0 at positive 1. We're looking for 3 of them. What is left right here? Now, you could use another P over Q and divide again like we did in the last one. But I see something special here. This is factorable. We just depressed our polynomial from a third degree to a second degree. So what do we have left is 1x squared plus 6x plus the 9. And factors of 9 that add up to 6 are plus 3 and plus 3. Which means, again, we have a repeating root, so x equals negative 3, not once, but twice. So negative 3 multiplicity of 2. So negative 3, which means, let's label these down here. We are going to pass through 1, but we are going to bounce at negative 3. Look at your leading coefficient. Your leading coefficient is positive. Your degree is 3, which is odd. So this is going to be an increasing graph. Increasing function here. Increasing function. So what does that mean? We're going to be going down over here and up this way because we're going to be increasing from the left to the right. So if you want to write your in behavior, I'll squish it in right up here. There we go. So as x is getting smaller, y is getting smaller. Why? Because we're decreasing in this direction. We're going down to the left. And then on the other side, as x is getting bigger, y is getting bigger. So this is your end behavior right here. So let's graph it. We are bouncing and passing. And if we look right up here, bazinga, there's our y-intercept. I think we can graph that. So we're bouncing, so bounce back down to there and then pass through here. There we go. That is what our graph looks something like. That's number 13. So once again, that was 12 and 13 on your review sheet that we did in class, or that was handed out in class yesterday. 2 more soldiers. Let's finish strong here. So here's some extra fun, and you can graph these or just watch as I do it. So this one is in factored form. We've got a tricky little minus sign lurking up front. Remember what that means. That means that we have a constant value of negative 1 up front, which means our leading coefficient is negative. What's our degree here? So our degree is 3 plus the 1. Our degree is 4. So negative leading coefficient, even degree, down and down. Down and down on both sides of the graph. Since this one's factored, it's kind of ready to go. It means our zeros are at negative 5 and that is a multiplicity of 3 and also at 2. Remember, this constant value up front has no part in the zeros. It only contributes to the leading coefficient. So we've got a 0 at -5 and a 0 at +2. Both of these have odd multiplicities. Multiplicities, your big word of the day. So they're both going to pass. So we are going to pass here and pass here. Let's see if we can find out what our y-intercept is. It's going to be ridiculously, actually small, or maybe large, we'll see. So -1, 0 plus 5 is 5, 5 cubed, 0 minus 2 is -2. So we end up with, yes, large, positive 250. So there's really not a physical way that I can show that, so I'm just going to show that by going way up to get there. Remember, we're passing through both of these. So pass and go way up, and then pass and zip down, down and down. So that's what our graph looks something like. Remember, odd multiplicities here. So multiplicity of 3. And remember, if it just is once, that's still an odd multiplicity. That is when we pass. We pass through those points. Last problem. Here we go again. Wanted to take another opportunity to show you one that is factorable. So 1, 2, 3, 4. If it only has 4 terms, try to factor it to see what happens. So if we have x cubed plus 2x squared minus 9x minus 18, what's giving it away is 9 and 18 are factors, or 18 is a multiple of 9 and 2 is a multiple of 1. That's why I'm thinking it's factorable. So split it down the middle, take out the x squared. What's left? X plus 2 over here. Take out the 9, what's left? X plus 2, yay. So we end up with x plus 2 times x squared minus 9 equals 0. Factor this, it's the DOTS. Be on the lookout for easy things to factor. So this one is x plus 2 times x minus 3 times x plus 3. 3 factors, distinct factors, which yields 3 distinct zeros. And all 3 of those zeros are just single roots, which means they have an odd multiplicity. So all 3 are going to pass. So we are going to pass at -3, pass at -2, and pass at +3. Our leading coefficient is +1. Our degree is 3. So we have an increasing function. So if it's increasing, we are going from the bottom to the top, left to right. So passing, passing, passing. Our y-intercept, remember, g of 0 would be 0 plus 0 minus 18. So our y-intercept, g of 0, is -18, which, you know, way down there. So passing, passing, way down low, and passing. The graph looks something like that. There you go. That is a solid review for our test on Monday. You're going to be awesome. See you soon.